So here is a linear programming problem, which means it is a system of inequalities, but it's a word problem. So what we're doing is we're gonna take this, we're gonna use the words to make two inequalities, or maybe more than two inequalities, and then we're going to graph them, and then we're going to use the graph to interpret the data. So marshes buying plants and soil. The cost of soil is $4 per bag. The plants cost $10 each. So I can already see that my variables are going to be probably X is the number of bags. Always define your variables first, and Y equals the number of plants. She wants to buy at least 5 plants, so there's at least, see that inequality, did you hear it? She wants to buy at least 5 plants, so remember Y is the number of plants, so Y has to be greater than or equal to 5, and she can spend no more than $100. Well, what's the total cost? So she's going to spend less than or equal to $100, right? You understand how I came up with that? And what's the cost? Well, it's 4 times X, because it's $4 per bag of soil, plus 10 times Y, because it's $10 for each plant. So there are my equations. Let's see if there's any other equations that I've missed. It says write a system of inequalities to model the situation, define your variables, and then graph the solution. So I defined my variables already. Well, I just erased it. But Y equals the number of plants, and X equals the number of bags. X equals the number of bags. You'd probably want to write them down here somewhere instead of up there, but to save space, I'm putting them there. Alright, so now let's graph it. What does Y is greater than or equal to 5 mean? Well, here's Y. Y is greater than or equal to 5 means that it is a 1, 2, 3, 4, 5. It's got to be greater than or equal to that line right there. Did I do it right? 1, 2, 3, 4, 5. Yeah, this is Y equals 5 right here. That line is Y equals 5, so it's got to be greater than this. Anything up there satisfies that inequality. Y is greater than or equal to 5, right? Now let's do this one. Let's do this in a different color. Let's go with purple. See if I can see this okay. That one we'll do in purple. So what are my solutions? Well, let's do that little trick I keep talking about. Plug in 0 for X, and now solve for Y. So 0, 10, and plug in 0 for Y, and solve for X. 25, 0. There are my 2 points. So 0, 10 is 1, 2, 3, 4, 5, 10 more up. There's that point right there. And 25, 0 is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm getting cross-eyed. Something around there. I might be off by a dot or two, but close enough. Let's take our graph. Let's draw our graph in now. Not close enough. Let's try that again. Good enough. Now, are those solid or dotted lines? Those are going to be solid lines because they have the equal to signs underneath them, both of them. So those are going to be solid lines. Now, is this going to be up or down from here? Let's find out. Let's find out if 0, 0, which is that point right down there, makes this true or not. Is 0 plus 0 less than 100? Is that true? Yes, it is. So it goes down. So where's my graph? Where's my solution? It's all of these points right in here. Those are all of my solutions. Or my, sometimes this books call that the feasible region. So that's my feasible region, and I'm going to erase the rest of these right there, and there's my answer. Now, sometimes they'll ask you to find this point. They didn't ask us to do that for this particular example. And you can't trust your graph. You're going to have to actually solve this system. It'd be pretty easy. Just plug in 5 right here for y. So 100, we can find that pretty easily. 40 divided by 4x equals 50. X equals 12.5. So that's 12. That is obviously 5. And it's 12.5. 12.5 comma 5 in case they wanted you to find that point. It would be that point. And actually, they will, when you get to the next level of these kind of problems, they'll ask you to find those feasible points right there. These 3 points right here are the points that you'll then use and you'll plug into another formula to find out what your maximum or minimum costs are. But we're not doing that particular problem right now. So there's your solution.